to just recap some of our upcoming webinars. Today we are presenting on variable refrigerant flow systems. This is the third of 5 tech topics that are being offered by the program, and these are offered every 2 weeks on Wednesdays at noon. So there's 2 more left in this series, so please feel free to join our upcoming ones. Additionally, these tech topic and the upcoming building analysis topics will be available for Multifamily Upgrade Program credits and also BPI continuing education credits. So if you're not self-reporting those through BPI, please make sure you do at the end of each webinar fill out the survey and your BPI certification number, and we can report those for you. Otherwise, it's up to you to self-report that. The multifamily upgrade building analyst topics, these are also a series of webinars that are going to be starting here at the end of May. These are designed to help you prepare for the building analyst exam, which these are all 1-hour sessions during lunchtime as well, and are available to anyone who would like to join. And lastly, on the VPI Training Series, there will be a diagnostic training on August 20th, which will be a full day. And there's also the opportunity to take the written exam on August 21st. The written exam does have a fee of $275, but this will be at the Stockton Energy Center, and more information on the written exam and location are coming. For the field exam, we're still working out some details as far as where that will be hosted, so more information will be available on that as soon as we know. So with that, I would just like to remind you everyone's on listen only. If you have any questions, please type them into the question bar, and I will help get them answered. With that, I would like to pass this over to Kyle Brumfitt from Partner Energy. There you go, Kyle.
All right. Thank you, Stephanie. Welcome everybody to the third installment of the tech topics. So today we'll be discussing variable refrigerant flow, which is acronym VRF. You'll see kind of thrown out throughout the slides. So just want to talk briefly about the theory behind the VRF system. So it's an air conditioning system configuration where there is one outdoor unit that serves multiple indoor units. So in your conventional split system, you would have one outdoor unit dedicated to one indoor unit. With the use of variable refrigerant, we're able to use multiple indoor units with one outdoor unit. So the term variable refrigerant flows refers to the ability of the system to control the amount of refrigerant flowing into multiple indoor units, enabling the use of many indoor units in differing capacities and configurations connecting to a single condensing unit. So unitary cooling systems basically work in the same manner as a direct expansion system, come in both a package and a split DX variety, and have the ability to vary the flow of the refrigerant, which varies the capacity in the system. Typically can achieve higher efficiency ratings than direct expansion type systems. Some benefits of the VRF, I've read up on some ASHRAE white papers, so I'm referencing ASHRAE white paper when I say this, but they're saying the site energy savings ranges from 51 to 85%. HVAC time-dependent value energy savings ranges from 31 to 66%. Now, this was based on a single-family white paper that I was looking at, so it took 3 properties throughout the state in multiple climate zones. So the results are climate-dependent you know, this again is single family, multifamily. When I model multifamily, seeing mostly within like the 20 to 30% ranges of your TDV savings. So it's not as high as what that white paper was saying, but they do have the capacity or the ability to reach high energy savings, which is basically the purpose of this slide. So by having variable speed drives on all those, being able to have smaller capacities on the indoor units and then the less outdoor units. So we'll talk about that. They can modulate down. So when you have indoor units or residential apartments that, you know, if you look at a load calc and it says, you know, it only needs, you know, like a half a ton or to a ton. Typically, those conventional HVAC split expansion valves or split DX systems kind of start out at 1.5 tons. So we're talking about right sizing the equipment. You know, you get penalized when you oversize equipment. So using these VRF systems with multiple indoor units paired up to one condensing unit really helps to right size the equipment as needed. All right, so there are two distinct types of VRF systems. There's a two pipe and a 3-pipe. Now the 2-pipe operates in either heating or cooling mode, standard operating mode. So that's very similar to your standard unit. It can either be in heating or in cooling. Now the 3-pipe is the heat recovery system, and this is where you find even more savings, and which is referring to that last slide where I was showing the HVAC site energy savings, TDP savings. They were using these heat recovery type systems. So you're able to simultaneously heat and cool 2 different spaces with the one condensing unit. So it's a very handy thing, and they basically share refrigerant and share load, taking heat out of one place and putting it from a place that needs cooling and putting it into a zone that needs heating. Just a quick kind of run through of refrigerant and how it works. It's basically you're taking the heat out from inside and you're releasing it outside. So when you're in cooling mode on an HVAC system, you're not actually cooling the space with, you know, you're taking out the heat, and so what's left over is the cool air that then gets mixed again with the space. So you know, through the evaporator in your indoor unit, you're able to take out the heat. The gas is at a liquid state at that time. And then under low pressure, it goes to a gas. So taking the heat, going over the indoor coils, heats up that vapor, or sorry, that liquid, turns it into a gas, and then as it's on its way out of the space, it hits a compressor, which then compresses that gas to a higher pressure and releases it to the outside air. And then it basically starts the cycle again through an expansion valve. And so that's basically, you know, I think just want to recap on how refrigerant works. So that's how you're going to be able to move the heat from outside into inside. And then with a heat pump type system, it's basically it's the same way, and it's just flipping, you know, with a valve on the heat pump system. It flips the way the refrigerant flows, and it's taking that outside heat and bringing that into the space in heating mode. So that's a little brief summary. A little bit more about it. Refrigerant flows through the compressor, which raises the pressure of the refrigerant. Refrigerant flows through the condenser, where it condenses from a vapor to a liquid, giving off the heat, so it's letting the heat out. If you ever go outside, you put your hand over the fan on the condensing unit outside, you'll realize that that's hot air, and so that's all that heat that's coming out. And then the refrigerant goes through the expansion valve, where it gets a pressure drop, goes back to a liquid, and it starts the cycle over again. So again, the refrigerant draws the heat from the evaporator, which causes the refrigerant to vaporize. The evaporator draws the heat from the space to be cooled, so what you're left over with then is cool air that goes back to the space, and it's just a constant cycle. So what the VRF system is trying to do, and it does, is it takes that unwanted heat, and through the refrigerant lines, you're able to then transfer that heat energy to another space that is calling for heating. So it's a very, very sophisticated system, and you're seeing them more and more prevalent in the market. So how we model these is what we want to talk about today, and how we model them for the program specifically. So a couple key things you want to know is basically, what are your outdoor units? How many of them are there? Are they a 2-pipe? Are they a 3-pipe? And how many indoor units is associated to that one outdoor unit? So I have an example. So if I'm just going to see if this clicks on, I wanted to show you a schedule that I have for a property that was using and utilizing the heat pumps and a VRF. This is a multifamily project, 10 stories, that are going through an upgrade, and they're changing out to a VRF system. So kind of box it out here. Basically, the floors 2 through 9, and the 10th floor gets a total of 4 condensing units that are going to be serving all those indoor units. So it's an air-cooled condensing unit. You can see it's got quite a large cooling capacity, 168 MBH and 189 MBH when heating. So basically that's a larger outdoor unit that's paired up to multiple indoor units, and it's splitting up that cooling capacity demand based on how many units it's connected to. So that's the outdoor units, and it's great when you're able, if a property is looking to do upgrades and they want to find room for maybe a solar thermal system or a PV system, or if they want to make a rooftop deck, or or whatever kind of upgrades they're going for. We've all been out there on the roofs of these buildings sometimes, and you see just like a condensing unit farm up there, and there's really no space, for anything else besides condensing units. So instead of having one for each residential apartment, you'd be able to slim that down, and you can use that roof space for something more, more desirable as the renewables, or just a place for the people to hang out, the tenants to hang out. So I know downtown Los Angeles, they change these out a lot, and they have rooftops, and then they put the solar thermal or the PV on top, and it works really nicely for the properties. All right. So that's your outdoor units, and then we have the same thing I wanted to show you as indoor units. And as you can see, these are all the indoor units. So there's quite a lot of indoor units for each resident. So it's AC 2-1, floors 2 through 9. So basically, if you're on the 3rd floor on this, it'll be 3-1, and so on. So there's a lot of indoor units that are matched up to there's only those 4 outdoor units. And then basically it shows you the capacity for each of those residential apartments. So if you remember before, the outdoor unit had 168 MBH. Well, on the indoor units under your MBH, you're looking at 15, 20, 12. So they're sized accordingly, and they're matched up accordingly to what their demand needs. So as you add up those capacities, and they should be within that 168 MBH total capacity, and they get to work together and share load and all that good stuff. Over here, it tells you what your indoor unit is going to be, and which ones are going to be matched up to with respect to the outdoor units. So just to kind of let you visualize how a mechanical set will be kind of laid out, which is very important to get when you're trying to model these for the program. You want to make sure you get a set of proposed plans to really identify the areas being served and how they're set up. So indoor units, they come in many different types. Ducted, non-ducted, you can have them concealed. You have these cassette units, is what they call them, and typically you can have, for apartment units, you're just gonna have one for each apartment unit, and you can think of it as well. And if you're single family or office spaces, you can have one condensing unit serving multiple indoor residential units. Or residential, so like your living room might have one, your bedrooms may have indoor unit, and if nobody's in the bedroom and it's not calling for any heating or cooling, then it gets to throttle that outdoor unit down, and you find a lot of those savings through the variable speed drives and the compressors and the staging and stuff like that. Here's a line diagram of that same property, just to kind of show you how they all talk to each other. So you have what's called a selector box when you're dealing with the heat recovery systems, and basically the selector box is kind of the gatekeeper of who needs the refrigerant. So you have your outdoor unit, which is kind of your main guy that's going to be there to help support and any of the unmet loads that either the indoor units can't share. If you can't get enough of refrigerant or cooling of capacity to cool that space through the heat pump and the heat recovery system, then your condensing unit kind of takes over and helps out with that. So you have an outdoor unit, then you have your selector boxes, and then you have your indoor units. And selector boxes are going to be matched up with different residential apartments. And I'm going to get into zoning here in a second, because it's very important to make sure that when you're using a heat pump or heat recovery VRF system, that the zoning is going to be set up in a manner that you're going to reap the benefit of sharing that load. So here's the zoning of that and sharing the load. So we have the selector boxes that are here in the hallway. They're basically one selector box for 4 apartment units. And when you look at this property is oriented north and south. So they are going to be able to share that load. If the south facing is in cooling and cooling load and a cooling mode, it's going to be able to use the north side units to pull some of that cool or take the cool refrigerant, because it's a heat pump, so it's going to change the cycle of refrigerant. As we talked about before, it's going to pull that from there, go to the selector box, and then disperse that to the indoor units. So these indoor units are ductless units, and they're located in the living room spaces, and then they have transferred grills that go into the bedroom apartments. So it seems simple enough, but it's something that you need to really consider. Or if you get a set of plans and you see that your client mechanical engineer may be putting in these systems, that the design intent of those systems is to share load, but they have all of the same units off one selector box that's all facing north, then you're not really reaping the benefit of that shared load demand mentality that it's intended for. So Another example would be if you're in an office space and you have kind of your perimeter open office areas, and on the outside by the windows, and then you have your indoor or interior kind of core office apartment or office cubicles, and they're able to then work with each other to share that load and keep everybody satisfied. So every indoor unit has a thermostat, so it's basically that's their control mechanism to run, obviously, or if it's going to go to heating or cooling mode. So you got one control for every indoor unit that shares one outdoor unit. It's a really great system, and the mentality and the thought of it is great. And you can what I like about them is that you have these small studio apartments, and as I mentioned before, you can get these indoor units that have a range. So maybe they are rated at 6,000 BTUs, which is like a half a ton, up to I don't know, ton and a half or just a ton of load. And instead of just kicking on and trying to deliver 12,000 BTUs, so there's, for a little background, 12,000 BTUs is equal to 1 ton of cooling. So if you can throttle that down to the demand that it needs, if the load's only, say it's really at the peak time, it really only needs a half a ton. Well, you don't want to put in a conventional 1.5 ton unit just to satisfy a half ton of load on a peak demand time of year. So in the height of summer, maybe it hits the need for a ton of cooling or whatever the peak demand may be, but it's only say 2-3 weeks out of the year. The rest of the year it's pretty moderate, and it doesn't need all that. When it is kicked into cooling mode, it doesn't need 12,000 BTUs to satisfy the load. So the ability to modulate down through the compressors, through the variable speed drives, it adds longevity to the system, the operating of it. So if you're operating a right-sized equipment, the system should last longer. If you're operating a larger piece of equipment on a space that does not need all of that load or that capacity, then it's going to just keep kicking on and kicking off, and things start breaking down because it's just oversized. And with the oversizing limitations in the code, with the ACA Manual J, D, and S, and those kind of requirements that are coming out that are being enforced more and more, the right sizing of equipment is going to be prevalent for us to show energy efficiency in the state of California. We need to really be conscious of the equipment that is getting specified and installed. I know that most of the time people do just an average square footage, square foot per ton type situation, and that way of the past is a way of the past. It's not something that is going to stand. I've had a lot of enforcement agencies ask for mechanical HVAC load summary reports and things of that nature, and you do get penalized in the Title 24 reports when you oversize equipment. So these smaller units are awesome when you can get down to the half ton, and it has that range. Is there any questions? I'm going to pause. Yeah, is there any questions right now? I can talk through.
Great timing. Actually, there's a question through the online thing, and could you explain how a VRF can be a package system if you have multiple heads?
I've seen the VRFs as a package system when you're still going to be serving your indoor cassette units. So yeah, I guess the term package unit in everybody's mind is just, everything's in one area. I guess it's not the best term to call it a package unit, but there there are systems out there that provide heat recovery in the package sense. So I can't really explain it much better than that.
Okay, great. That's the only question we had at this time.
Thank you. So within EnergyPro, this is what we all need to know about, is how to model these things in EnergyPro. You have your system level, which is your outdoor unit, and your system type. So in EnergyPro, you go into the system level, you're selecting your outdoor unit. Typically, in this sense, we would be selecting both, the heating and cooling, and the fan energy, right? And basically the whole system would go in there. Since these are going to be matched up with multiple indoor units, we're going to be providing the system level. At the system level, we're going to be basically saying it's a VRF system. The heating type is a heat pump, and you're going to be getting your base. All your performance information is going to be based on HRI. Remember we talked about HRI certificates. I think it's probably one of the first webinars. It's very important to obtain the information you need for that space or for that system. HRI and the CC appliance database are really the only two places you should be going to get that information for the performance of your system. So again, here's just a copy of an HRI certificate. And the thing they want to note is that the fan associated to the indoor unit is going to be put somewhere else. So we'll get to that in a second, but you're basically only be putting in, so here's an example. You have your system tree, about the building tree, the system level, and you're putting in your heating. You're putting in your heating, and you're putting in your cooling, and you're calling it a heat recovery system. So this is the total heating and cooling capacity of that big outdoor, or the larger outdoor unit. In the example I showed you is a 168 MBH outdoor unit. There's 4 of them. So this is that one system that's serving multiple indoor units. Heat recovery, you want to make sure you're selecting that if that's your 3-pipe system. It's a 2-pipe system, it's not going to be a heat recovery system, and the modeling approach is going to be similar to, or the modeling inputs is going to be similar to what you have for your conventional. However, you're still going to have that indoor unit you need to put in. So less systems in your building tree, larger system information going in, and then it's going to be split up based on your indoor units that you select. So at the zonal level of their building, this is where you're putting in all your indoor units. So you're going to go to the mechanical tab on the zone level. So people may not be familiar with that unless you do modeling of a lot of like VRV, variable refrigerant volume systems, or those larger commercial spaces. If you're doing any commercial modeling or stuff like that, you might be familiar with the mechanical tab. But if you stick with the multifamily and the apartment complexes and stuff like that, then you're most likely never really in this tab. So you're going to go to the mechanical tab. You're going to click a new guy and put a new system in. Call it a VRF system, and you're going to be putting the heating, cooling, and sensible output of that system. So this is, you're going to get your, say it's the 1/2 ton to 1.5 ton indoor unit. You're putting in that system information and that's going to go into the residential apartment. So this is again where you're going to be putting in, so instead of putting your fan energy under the system level, you're putting your fan energy under this indoor unit zonal level. So the fan associated to that space, and that's where you're going to get your CFM. And then remember, we talked last time about the design horsepower, the brake horsepower. You're going to need to calculate your brake horsepower, and I have a slide again to refresh everybody's memory on that. But this is where you're doing all your CFM, your fan energy is all going into the mechanical tab. Similarly, you're going to be putting in your pipe length that's associated to that one indoor unit serving that one residential apartment. That's also going to be put into this zonal level. So here's a little flow diagram of it. Here's your system we just talked about. That's your big outdoor unit. Here's all your residential apartments that are talking with that outdoor unit and talking with each other because it's a heat recovery system. You go to the mechanical tab. This is your zonal system. Click on click on that guy to open it up. On the general tab, you're going to be putting in all the heat output and cooling output, sensible output information of that one system. You're going to click over to fans, and in the fans, you're putting in your flow rate of that CFM, your design horsepower, and then the drive efficiency of that system. So that's their zonal level, and then obviously underneath that is your room and your room information, your walls, your windows, all that good stuff, envelope components. So just to recap on the system fan power, so we model using design power. So that's your fan rated at operating conditions. It's very important to know what actual motor operating horsepower is. It's useful information for when troubleshooting problems and doing either modeling or performing energy audits. Fan energy is a big component to energy consumption. Understanding the elements and process of basic motor horsepower calculations also increases the awareness of energy consumption to yourself and to your client, to your tenants, to everybody that's reaping the benefit of these systems. So again, here's just the things you need to know to get a brake horsepower. This was a slide from the last guy that I did, last presentation I did. It's a one-phase horsepower. You need to know the volts, amps, percent efficient, and the power factor. So this is just that calculation over again. 746, that's your watts to horsepower. And so since we get volts and amps equals watts, we're dealing with watts here, and then we want to end up with horsepower. So a rated horsepower of a motor that was 350 horsepower is the actual operating condition of that motor would be 201. So obviously you're not going to have that as your indoor unit on these things, but it's just the math is really basically what I'm trying to show here. Okay. So is there any questions as I go into the program and the state stuff, Stephanie?
Yeah, there are a few questions. One question is there a proportional thermostat for both 2-pipe and 3-pipe systems at the zone level?
Proportional thermostat? There would be your thermostat at both. You would have each indoor unit would have its own dedicated thermostat. Does that answer the question?
I think so. She does have a follow-up question. Are all values for the BHP calculated readily available?
Yeah. So how to calculate brake horsepower?
Mhm.
Yeah, I use Google if I need to remember what the calculations are.
Okay, great.
So yeah, you can just Google it; it'll come up. If you have 3-phase, single-phase, you'll get all those calculations there.
Great. And then there's just another question about the difference between low-rise and high-rise and using the mechanical tab. How would the zoning be addressed in low-rise? I think the question is, their understanding is that the mechanical tab is only used for high-rise?
No, you can model if you open up your if you're in EnergyPro and you try to open up any kind of sample VRFs, that's how they're going to model it on the indoor, on the low-rise ones as well. So you're gonna have that outdoor condensing unit with your one indoor. The mechanical tab still works. As
Okay,
far as
and
I haven't had any issues with it.
okay, and that is it for now.
Okay. All right. Feel free to ask us questions whenever, guys. So, so I wanted to talk about the program versus the state. You know, it's no, we're not going to court or anything on this stuff. So, it's just the differences, I guess, program versus the state. So the VRF system is acceptable means to show energy savings in the multifamily upgrade program. Just want to let everybody know you can submit to the program a calculated energy savings when using a VRF. On the other hand, currently VRF modeling is not approved for Title 24 permit applications. So when you want to do a Title 24 report, or if you have a mechanical engineers doing a Title 24 report and he wants to use VRFs, that they're going to have to use, for compliance, they're going to have to use a base minimum efficiency split heat pump and show compliance with the building in that fashion. However, California Title 24 2013, the standards have incorporated base minimum efficiencies of VRF systems, and they went to the great detail to really lay that out. It wasn't in the 2010, 2008 code. So with that being said, my expectation is that the CEC will approve the VRF systems for compliance modeling in the future. Now that we're on the new back engine on the code compliance, you know, we'll be able to do that. We'll be able to model it and show it. The issue before was the DO2 engine just didn't do it properly. So yeah, that's basically, you know, it's my guess, but I wouldn't imagine. I think it's a pretty good educated guess if you look at the code, and I wouldn't imagine they'd spend time putting in base minimum efficiencies of a VRF system if they weren't going to let people use it as a means of compliance. So for the program, you're going to have to show a two modeling approach. So you have to do it that way because of the zoning, right? So if we go, you know, I hate to do this, but if I slide back up and I show you, you know, this is how you got to zone out your outdoor units, you know, with your indoor units. Typically, you're going to have, if it was your existing conditions, you may just have, you know, that one split HVAC type and a multiplier, and then have your zones and all that. But for VRF, you want to zone it accordingly, or by orientation, and then also, I mean, if you just try to do a straight edit replace with a VRF system, I mean, you got to add the indoor units. You got to, you know, you're not going to reap the full benefit of that savings. So the two model approach is how the program wants to see it done. And what you would do is that the existing model, as you know, basically everything is existing, no alterations. You're not going to be using the alterations tab in this one. You're just going to be putting in what you found out on site, and that will be your baseline. And then you'll have a VRF model that has the updated systems, the improved systems already in it, and the indoor, you know, under the mechanical tab, you're going to have the indoor units shown. And then on the res alterations tab, you're going to put all your upgrades. Now, the reason, the idea behind it is that you're really then showing to the program that there's an apples-to-apples comparison. They're able to see where the energy is similar, where the energy savings is happening. This is the easiest way to convey this information to your client, and the easiest way to have it QC'd by the people at TRC. So they have basically said that it's a two model approach, which totally makes sense in my mind. And I think after you you kind of mess around with installing or not sorry installing, but working with the VRF modeling approach, you'll understand why. Easy way to understand why is that, if you did the alterations tab in EnergyPro and you changed out, you say you're changing out your HVAC, it does it universally, right? Well, you're not going to have one big condensing unit for one individual or, one indoor unit, one residential apartment. You're going to have a larger condensing unit with smaller indoor units, and so, in that logic, it makes complete sense. So a couple important takeaways for this webinar. Know your systems. Know how they communicate. Know if you're dealing with a 2-pipe or a 3-pipe, know where thermostats are going. Know how they're going to talk to each other. Know your selector boxes. Know the zoning. Those are all very important things. Make sure you have all the information you need. How many of the indoor units do you have? Which ones are matched up to the outdoor units? A plan set is critical to get because you want to really see where everything is getting served, right? And all your results are going to be climate dependent. Just like cool roofs might not be really great in certain climates, but they work great in other climates. It's the same thing with the way that the mechanical systems work. I mean, same thing with any of these, wall assemblies, roof assemblies, all that stuff. It's all climate dependent. More is not always better. So you have to kind of keep that in mind. And after reading some white papers and some information on VRFs, and sometimes you find that it's not beneficial in certain areas, but most of the time it is. Most of the time you're going to see really good savings to it. There's a cost implication to all this. Obviously, the VRF systems are more expensive, so upfront costs and payback is something that you might want to, start showing when clients ask, what about a VRF system? You want to be able to explain that to them and show, it might cost you more up front, but your payback is quicker. Total energy savings is this. Tenants use less energy. Your building's operating and functioning at a more sustainable method. So, are there any other questions, Stephanie?
There's just one question. I apologize. I read this incorrectly earlier. Someone was asking about where do you find the actual values to be used in the BPH entry for EnergyPro. Are those located on the cut sheet or the spec sheet, or where are you able to find those?
Cut sheets typically have that information you need. So you're going to go out. If you see nameplate's going to have it. In my last webinar, I showed all the information was on the nameplate. All the information you needed was on the nameplate that I showed an example of. Some of the smaller fans or smaller fan energy, smaller systems, you might need to do a little bit of digging to get, but they're definitely out there. Cut sheets are probably the best place I would go to figure that out.
Great. Another question is the electric resistors included in the model. Not quite sure I understand that question. The participant who entered that in, if you could just clarify your question, that would be helpful.
I think they might be asking if there's added electric resistance heating to the space and how that is put in.
Possibly.
Yeah, maybe.
Let's see here. His response is typically heat pumps use electric resistors when no outdoor air is available.
It's actually depending on your climate zone. So, like down here, I'm in Los Angeles, down south, you don't see electric resistance added to heat pumps ever. It's basically if you needed that extra boost to get the heating you needed. So we don't see that down here. It's not just because of outside air or whatnot. It's really just if you need supplemental heat to the space. But how you model it, yeah, he's got a good point on that, or she, whoever the participant is, has a good point on it, because you put your added resistance up in your main system tab. So he's basically, or she's basically saying, where does that go? I would probably quantify it into the heating output of your indoor mechanical unit, because there is no electric resistant section in there. I haven't seen the VRF heat pumps with the added or VRF systems with the added electric resistant component to it. It's not something that I've seen in the systems. I've seen it on first company units and first company heat pumps or some other heat pump indoor unit. You can add an auxiliary heat, and you can have that as an addition to your total system heating capacity. But I haven't seen it on the VRFs, and if you do see it on the VRFs, where I would put that added auxiliary heating component would be in the heating output of my mechanical tab.
Okay, great. So there was just one more question about the thermostat type on slide 20 that you had. The question is the thermostat type always proportional for both 2 and 3 pipe systems?
I'm not exactly sure. I think it would be. My guess is it is.
And we can follow up with that participant afterwards as well.
Okay, that'd be great.
All right. We'll give everyone just another minute or so to type in any more questions. But I just wanted to remind everybody that the webinar today will be posted on the program's YouTube page within a day or two of this presentation. At the end of the call, please be sure to fill out the survey and enter in your BPI certification number if you'd like that to be reported. And we will also record those who attended on today's webinar in the PG&E Multifamily Upgrade Continuing Education log. With that, doesn't look like there's any more questions that have come in. So I'd like to thank Kyle for the presentation today. If you do have any follow-up questions, please feel free to email Kyle, Michael, or use the program Multifamily Upgrade at trcsolutions.com, and we will be happy to answer any of your questions.
Okay, well, thank you, everybody.
All right, have a great day.
Bye-bye.